Good afternoon. Today I'll be walking you through the updated progress I've made on the Educational Technology final project up to Milestone 2. Again, I'm on the development track and am building an analytical dashboard for students and teachers called StudyBuddy. A descriptive summary of the tool that is being proposed is a learning analytical dashboard that can be used by students and teachers to track their performance in the classroom. The tool is called StudyBuddy as its purpose is to promote the strengths and weaknesses in the level of understanding and information retention of topics in the classroom. The tool will consist of widgets or visualizations to track metrics that describe a student or class's understanding level of a section or chapter. The topics will vary by course, but for the most part align with textbook section or module names. Metrics will show accuracy level of questions on exams, homework assignments, and quizzes by section and chapter, as well as information regarding the time spent and confidence measurements on each of these questions. From the data architecture design discussed in Intermediate Milestone 1, there's only one small change. Instead of implementing an AWS glue job to move the data from S3 to Redshift, the Redshift copy command will be utilized. This will reduce the number of jobs needed for the data flow and remove the need for 2 additional crawler jobs in AWS Glue. Figure 1 shows the updated architecture design, while Figure 2 below shows the old data architecture design. And here you can see in the old data architecture design, both the data from RDS and the online platforms were moving to Redshift through Amazon Glue. But in the new one, we have Amazon S3 independently moving to Amazon Redshift using the Redshift copy command instead of utilizing Amazon Glue. As the data architecture diagrams show, the data from both the operational and online learning platforms have been consolidated in the data warehouse. The operational data was replicated using an AWS glue job from RDS to Redshift, and the second job was a Python script that went from the different files created by Amazon Kinesis Firehose in S3 and runs the Redshift copying command to move the unstructured data in S3 into a Redshift table. And we can look at that in the AWS console here. Here is the glue job that well, here are the connectors that connect from RDS to Redshift. And then for the S3 to Redshift copy command, here you can see we log into the database using our Redshift connector, and we get the S3 metadata through connecting through the session, and it's just a simple for each file we'll run the copy command into the Amazon Redshift table. Part of the work also for this milestone was establishing and finalizing the widgets for the visualization dashboard. And here you can see for the student dashboard, we have widgets to track accuracy for accuracy of the questions based on the correct flag in the data, time-based metrics, which will be visual widgets based off of the question duration, and then uncertainty-based metrics, which will be based on the number of answer switches that a student performed per question. And then another layer of aggregation will be used to create an overall area of improvement groups, and this will be based on all the metrics. And so now that the data has been moved to Redshift, we can combine and aggregate the data. This means joining the fact and dimension data from the university with the question data from the learning platforms. The aggregations will be used to calculate average grades for a section, chapter, or course, as well as average time per question and the number of answer switches. This work will be done in PL/PG SQL store procedures, stored and called in the Redshift cluster in order to create the final tables. And as you can see here, in Redshift, we have this is a metadata table that shows the database name, the schema name, table name, and the number of rows. And these are the tables that we will eventually be joining between to create our final tables that the widgets will query. Now we will move on to the visualization implementation that is to be completed in the last sprint of the project. Once the final aggregation tables are made, queries will be written to provide descriptive analytics to students and professors. These queries will be turned into widgets that will make up a visualization dashboard in Amazon QuickSight, which is Amazon's business intelligence tool. Walking through the task list, we have completed all of the intended work up to milestone 2. And then for the next phase, the next sprint in phase 3 would be to generate the logic for tables, the data mappings, data models, and DDL for the final tables, and then building the visualizations, orchestrating these jobs, testing, and then creating connection for the consolidated data store visualization tool. The only request for feedback that I have is, as a potential user of the online analytics platform, which widget do you think will be the most helpful of the four main sections that we have right here: the accuracy-based, time-based, uncertainty-based, or an overall score? Thank you all.